So my weight, which is acting straight down, my weight can be written as W sine theta I hat plus W cosine theta J hat. Because I said I hat was down the ramp, and the part down the ramp is W sine theta. Now watch out if the person writing your tests is a complete jerk, and instead of giving you this angle down here, he gives you this angle up here. Just beware. The jerk or just absent-minded. So I am claiming I'm going to take this force diagram right here, and I could actually do. I'm going to take that and I'm going to redo that force diagram. So I'm claiming that instead of writing it that way, I could write it so I have y going this way, I have friction going this way, and then weight, I have a component this way, which is that should be negative there, minus W cosine theta. I have W cosine theta acting that way, and I have W sine theta acting this way. I'm making the claim that this and this are the same force diagram. All I've done is take weight and break it into its components. And that is the decomposition phase. Right, anybody still needs this? Next step, the E, the equation of motion. I consider this, sure, I know I've stated it in at least one class, most important equation that I consider the most important equation in physics, F equals ma. This is the template for equations of motion. The left-hand side is the total force, right-hand side is mass times the acceleration. So when I look at this over here, one of the reasons for breaking it into components is I now have, well, I know my I hat form, or I hat parts are here, and my J hat parts are here. I'm going to do an equation for each part. I hat, J hat. So we'll do it this way. I will then, after we get the basic equations, I'm going to do it a longer way just to justify why this works. I'm not saying I hat equals. Please don't put an equal sign after I hat. All right, so my I hat equations, the way you do it is, first off, what are all the forces, looking at this diagram right here, all the forces that are acting in the positive I hat direction?
W sine theta.
Minus all the forces in the negative I hat direction. Somebody just mumbled it, I think.
Friction.
Thank you. All right. Those are the only forces in that direction, equals mass times my acceleration. Well, I know my acceleration is in the positive I hat direction. So, yeah, A. Now the J hat. What are all the forces in the positive J hat direction? Minus, what are all the forces in the negative J hat direction?
W sine theta.
Take two.
W sine theta.
Take three.
Cosine.
The other one, cosine.
Cosine, okay. Oh, negative force.
Equals mass times, what is the direction, what is the acceleration in the J hat direction? If it's going down the ramp, we said that was I hat, J hat's perpendicular to it. What's the acceleration in the j hat direction?
0.
Yeah. And this is why we chose our coordinate system the way we did, is so that one of these equations is going to be equal to 0. Questions to hear before I do it a slightly different way? Okay, it's a longer way, but just it's going to justify this. All right, if I plug straight in F equals MA, I got my four forces over there. I have W sine theta I hat plus Y J hat, just working my way around, minus friction I hat minus W cosine theta J hat is equal to mass times my acceleration. Well, my acceleration is in the direction of I hat, so that would be MA I hat. I can rewrite this slightly and get my I hats together, so I have W sine theta I hat minus F I hat plus Y J hat minus W cosine theta J hat is equal to MA I hat plus 0 J hat. Or W sine theta minus F I hat plus Y minus W cosine theta J hat is equal to MA I hat plus 0 J hat. I have these equations. I hat and J hat are independent of each other than they're at a right angle. If this is true, then the I hat parts must be equal and the J hat parts must be equal. In other words, W sine theta minus F must be equal to MA. Y minus W cosine theta must be equal to 0. So that's the justification for what we've done here. So equations of motion, done. Substitution. There are certain independent formulas that will occur regardless of the problem. These two are problem specific. This is the box going down a ramp. But there is an independent formula for weight. And what is the formula for weight? Or perhaps I haven't done that yet.
I don't think so. Mass times G.
Say it again?
M times G.
So M times G? Yes. So W equals mg. Where this comes from is if I have an object in free fall, what are all the forces acting on an object while it's in free fall?
Gravity. Or weight.
That's it. Ignoring the resistance. If I plug in, I take Newton's second law of motion. Still bogs my mind really excited. So the total force acting on it is just the weight. That's going to be equal to the mass times the acceleration. Well, the only force I have is the force due to gravity, acceleration must be the acceleration due to gravity. So W equals mg. So this step, I'm going to take mg and I'm going to plug it in for weight. And so I now have mg sine theta minus the friction is equal to ma, and then y minus mg cosine theta equals 0, or I'm just going to move that over. So y equals mg cosine theta. And now we go into what Giovanni was so anxious to do earlier. We set friction equal to 0 because the original problem was frictionless. If I'm solving for acceleration, well, actually, I now have ma is equal to this. Mass cancels out. And so the acceleration is just the acceleration due to gravity times the sine of that angle. This equation right here has no impact yet. When we bring friction into it, it will matter. But A is equal to G sine theta. So if we're on Earth 2 or 3, G is 10 meters per second squared. And let's put the angle at 30 degrees. And we end up with 5 meters per second squared.
What is the 30 again?
I just said make it 30. Okay. Because I can do sine of 30 degrees in my head.
What is the A equals G sine?
From the first equation, when the friction goes away,
Yes.
we're left with mg sine theta equals ma. The masses cancel out, and I'm left with A equals G sine theta.
Okay.
That's the solving part. Just a slight warning that makes it sound more ominous. Getting the sines and cosines backwards on the box on the ramp when you're breaking the weight up could cause issues. If I have a several step problem and part C depends upon part B, there have been situations where you get sine and cosine backwards, which suddenly changes whether the object accelerates or not, or has zero or non-zero acceleration. If you, generally, I see a mistake, I look at the process that a person goes through, but occasionally somebody will make a mistake that just completely oversimplifies the later part of the problem. I've survived many courses on partial credit, I believe in it, I'm a fan of it. However, if you oversimplify a problem because of a mistake, then I don't get partial credit. And probably didn't need to be said. Stream of consciousness. And I think finally, I'm letting you out actually on time because, or slightly late, because the class is over at 1:50 and not 1:45 as I believe in some classes in the past. And